Hi, I'm going to be presenting to you section 2.2, Solving Equations. And this is an online tutorial. It is not intended to be a teaching demonstration. I'm not going to teach section 2.2. I expect that you'll read the book either before you see the video or afterwards, maybe both, probably a good idea. And I'm just going to go through some of the examples that are in the textbook. It's probably a good idea to have your textbook open and follow along with me as I do things step by step. And I'll explain the steps that I'm going over, but I'm not really explaining the whole section. And that means that there is some material in the book that I'm not discussing that is good for you to read. I will begin in section 2.2 on page 2. Let me write that down. Page 2.2-2, and we're going to start with example 1. And in example 1, we're asked to solve the equation. Let me take a look here. 3x plus 5 equals 17. It's important with even simple problems to do things step by step, one step at a time, so that if we ever make a mistake, we find out if a mistake is made, we don't get the right answer somehow, then we can go back and check our work and see what it is that we did after each step. I'm going to be writing down some explanation, or I'll just be using it verbally here, as to what's happening at each step. But the key to solving any equation, in the end, is we need to isolate the variable. And in this case, our variable is x. Everything else is a number. And the 5 is called, for example, a constant, and it needs to be eliminated. And 3 is a constant. It's called a coefficient times x. It needs to be eliminated as well. The 17 will, in effect, gather all of these numbers over there in one way or another. And x will be isolated all by itself. The way we do this is to eliminate the constant plus 5 first. And that's explained, why we do it that way is explained in the book. But here I'm just going to let you know that we need to eliminate the constant first, always. And then we'll eliminate the coefficient. And we do so by adding the opposite of 5, which is negative 5. And I always put an equal sign between them to make sure that I'm adding on each side of the equation. I'm adding a negative 5 on the left side, and I'm adding a negative 5 on the right side. It also helps me to keep the equal signs lined up so that my work is neat and easy to read and easy to follow for myself if I need to go back and check my work, or for someone else if they need to check my work, such as a teacher or a student or someone else who wants to learn and benefit from this. And that's you, I imagine. When we add these together, we will get 3x, and then the whole purpose of adding a positive 5 and a negative 5 is so that we can add them to 0. And thereby eliminating them or clearing that number 5 from the left side and away from the variable x. Of course, to complete this, we have this being equal to 12. And now we have to eliminate the 3, the coefficient. Because it's being multiplied times x, I'm going to divide by 3. Dividing by 3 will actually allow us to create a new coefficient of 1 right here. That becomes 1x. And that's what we want, because now 1x is just x. It's all by itself. It's isolated. Of course, 12 over 3, 12 divided by 3 is 4. And we have solved the equation. Well, we've got an answer. We want to make sure that the answer that we have is correct, and so we do a check off to the side. We're going to check x equals 4 into the equation. Now, this means when we check x equals 4 that our variable x becomes 4. And everything else is the same, and we'll make sure that the left side is equal to the right side. The equation says we have 3 times that x value, which is 4, plus 5, and they must add and combine to equal 17. And we can continue to and see that they indeed do. We get 12 here plus 5 equals 17, And 12 plus 5 is 17, so we know that that's true. And so therefore, this is our solution. And that we've solved the equation, x equals 4. If you have any questions on that, please send me an email, or anything else in this presentation. Please send an email and or write something on the discussion board if you're in the online class, and we'll get any questions you have answered that way. I'm going to erase everything now and start with the next example, which will be example 2b. So I'm going to erase all of this. We're now going to go to page 2.2-4, example 2b. And that example says we have negative 3y minus 8 equals 2y plus 27. Now in this one, when we talk about isolate the variable, you might ask, which one? There are two variables. We see a variable here and a variable here. And so which one are we going to isolate? Well, the truth is, in the end, they're the same variable. If you think about it, we're going to get an answer somewhere. We're going to get an answer of y equals, I think we're going to get a 7 or something. I'm not exactly sure, but whichever answer we get for y, when we check, let's say it is 7, we put that 7 right here into y, so it becomes negative 3 times 7, and we put that very same 7 into y here, so that becomes 2 times 7. And when we put them in to the equation, then we check to see that it's accurate, but recognizing that it's the same y. This y here is the same as that y. So when we talk about isolating the variable means isolate one of those y's, and really we need to get them together to become one variable term. The way we do that is to add the opposite of one of them to each side. And I'm going to choose to add 3y to each side. I'm going to put the equal sign there and plus 3y. In doing so, we'll eliminate y from the left side. This will become 0 and just minus 8 or negative 8. Here we'll add and get 5y, and we'll have a single variable term. In a sense, by getting these y's together, we're doing a preparation for solving. So when an equation is more complex, we want to prepare it by doing something, moving, adding the opposite of a term, or so we can get the same y term together. Sometimes, as we'll see in a moment, in example 3, where we need to maybe combine like terms on one side, or distribute, or something along those lines. We prepare the equation for solving. This is one of those steps where we're preparing the equation to be solved by getting the y terms together till we have a single variable term. Let me continue here. As I said, we get 0 from the negative 3y plus 3y, and a negative 8 or a minus 8. This becomes equal to 5y plus 27. And now we're in a situation where it looks kind of like the first example we did, where we have a coefficient. Here we have 5 times y, and we have adding a constant, in this case plus 27. So we've got to clear the positive 27 and the 5 times, and we're going to do so by adding the opposite of 27, negative 27, to each side. And in doing so, we'll get a negative 35 here, equals 5y, and the positive 27 and negative 27 become 0 and don't need to be written down. Next, to solve, we'll divide each side by 5. And what we write at first is negative 7 equals y. But it's a very good habit to write it so that the variable is on the left side. And that very good habit won't come into play necessarily right away. I mean, we see here that, the answer is y equals negative 7, whether I write it one way or the other. But writing it this way, where the variable is on the left side, will be especially helpful for later in Chapter 2 when we have to work with what are called inequalities. Don't need to worry about that right now, of course. But it's important that we get into this habit of writing the variable, whether it's y or x or w, or whatever variable, on the left side in the end. So this is hopefully the solution. Well, we can check for sure if it's the solution by doing a check off to the side. We want to check y equals -7. And as remember I said I thought it might be +7. It turned out to be -7. And to verify that, when we put -7 in for y, we're going to put it in for this y here and for the y that's over here. Each of them become -7. Let's see. -3 times -7. And I'm using parentheses for the times, so I don't get confused about that. -8. And we want to know, does that equal 2 times y, again, -7, plus 27? So I'm going to have to do a little arithmetic here. This is not algebra now. This is just some arithmetic, order of operations maybe. We'll multiply first to get here a +21 and a -8 equals here a -14 plus 27. 21 minus 8 is 13. -14 plus 27, could do that off to the side. Yeah, it's also 13. So they're both 13, and we can say, oh, that's true, and that means that this is the solution right here. Y equals -7. You might be wondering in this process about something I did in the very beginning. By adding 3y to each side, I eliminated the variable term from the left side. But could we have eliminated the 2y from the right and gotten the same solution? What do you think? Well, I think, yes, you're right. We could have done it that way, and that thinking is correct. Let me just off to the side over here show you how the problem would be solved in that way. I'll do it relatively quickly. Let me rewrite the problem as, again, -3y minus 8 equals 2y plus 27. And I'm going to start this time by eliminating the 2y from the right side. -2y minus 2y. And they're equal to each other, so I want to make sure that I'm consistent in one on each side. This becomes -5y minus 8 equals 0 with the y's, equals 27. And now to solve this, we're going to add the opposite of -8. Oh, excuse me, better try that one again. We're going to add the opposite of -8, which is +8, to each side. And the result is a -5y, adding to 0 with those 8's, equals 35. 35, that's right. This time we divide by -5 each side. And the reason we want to divide by -5 is, as I showed you in example 1, we want this to be 1. And the only way that that's going to be a 1y is if we divide a negative by a negative. So we want the sign here to be the same. -5 divided by -5 is a +1y. So we don't want those to be opposites. When we're adding, yes, we want these to be opposites. But when we're dividing, we want them to be exactly the same so that we have a 1 times y. And y equals -7. Same answer we got before. We know it's the solution. We've already done the check. I'll just circle that, but indicate it's the same thing here. And yes, you don't need to do each way. I mean, one way or the other is fine, whichever you choose. But I wanted to show you that whichever you choose, by eliminating the variable from the left side and getting it all on the right, that's how you might prepare the equation. Or, over here, eliminating it from the right side and getting the variable on the left only, preparing the equation that way. Either way is fine. Some like to have everything on the left side, so they'll always eliminate the right side variable. Some prefer to work with positive coefficients. And so sometimes you have to decide, well, which one am I going to choose? And I want to end up with a positive coefficient. So, that's an option. To get the positive coefficient, you always would choose the lesser of the two values. And actually negative 3 is less than 2. It's to the left of 2 on the number line. But either way you choose is fine. You should get the same solution, assuming you do everything correctly, and I sure hope that you do. Again, do a check to make sure that it's correct. We want to make sure that one side is indeed equal to the other side. Okay? Let's move on to example 3 in section 2.2. And I think that I will do part B this time, example 3B. So we're on, whoops, let me get my pen here. Page 2.2-6, example 3B. And 2x plus 6 minus 8x is equal to 10 minus 3x plus 2. Now, in the previous example, I mentioned that we need to prepare the equation for solving. And that might mean different things in different equations. In here, one way that we can prepare is to recognize that we have an x and a negative, actually a 2x and a negative 8x on the left side alone. Those are like terms and should be combined. This is part of the preparation. Likewise, on the right side we have a positive 10 and a positive 2. Again, like terms, and they should be combined before, well, not before, but as preparation for solving, before we figure out what we're going to do with the rest of the equation. So, let's go ahead and combine those. And 2x minus 8x is a negative 6x, plus the constant 6 that's already there that didn't combine with anything. 10 plus 2 is 12 minus 3x. And we've made a simpler equation out of this. We've done things correctly. We have two variable terms, so as in the previous example, we have to either get everything on the left side, excuse me, not everything, but the variable terms on the left side or the variable terms on the right side. And as you've noted in the last example, it doesn't matter. I'm going to choose to add 6x to each side. So plus 6x equals plus 6x. And in doing so, we'll eliminate the 6x from the left side and get left a positive 6, or just 6. And this becomes 12 plus 3x. Negative 3x, positive 6x becomes positive 3x. And now we're to the point where we saw in the very first example, where we simply need to eliminate the constant first, and then, in a separate step, the coefficient. So I'm going to eliminate the constant by adding its opposite. That'll be a negative 12 to each side. And I'm going to combine what we have here. 6 and negative 12 is a negative 6 equals, the 12s become 0, and we're left with 3x. Divide each side by the coefficient 3. Not its opposite, but exactly 3. And this time we'll get negative 2 equals x. X equals negative 2. Remember how I was going to turn that around. And for this problem, I'm going to be done. Normally I would do a check, but it's in the textbook. So you can see that the check has been done. Let me check to see that the check's been done. Yes, and it is true. So that is indeed the solution. I'm just saving us some time here. So you can do that, look at that in the textbook. I have one last example to show you from this section 2.2. It is example 4. It is found on page 8. And I am again going to do part B. And I won't do the check because the check is in the textbook. So you can look at that. This is, again, page 2.2-8, example 4B. And let me take a moment to read it and to write it down. 3w over 2, or 3w divided by 2 if you want to say it that way, plus 1 equals w plus 9/2. And to prepare the equation for solving, we have to do something a little bit differently this time. What we have to do is to clear the fractions, or clear the denominators, however you want to think of it. Really, when I say clear the fractions, we are indeed clearing the denominators, because we want to end up without any fractions at all, but we'll still have numbers in their place. We want to clear the denominators, and the way we're going to do that is to consider what is called the LCD, the least common denominator. Well, in this case, we see only two denominators, and they're both 2. We actually, so that's the least common denominator. We actually want to eliminate the 2's, but it's not just crossing them off. We have to do things methodically and correctly, and what you're learning about equations is that whatever you do to one side, you must do to the other side as well. So we are going to actually multiply each side of the equation. I'm going to simply rewrite the equation from the start. We're going to multiply each side of the equation by 2. And you notice I'm going to use parentheses here to indicate that I'm multiplying everything by 2, not just the fractions, not just the 3w over 2 and the 9/2. I'm going to multiply everything by 2. And that means that we need to take this 2 and distribute it to each of the terms that are inside the parentheses. Everything will be multiplied by 2. The way I'm going to show this next step is I'm going to, all the 2's and times will be in red and everything else will be in black. So it takes me just a little bit of time to create that for you. 2 times the 1 as well, and 2 times the w, plus, here again, 2 times the 9/2. So every single term is being multiplied by 2, whether it has a visible denominator or not. And multiplying 2 times 1 is quite simple. Multiplying 2 times w is quite simple. When I multiply a fraction, it's easier actually to multiply a fraction times a fraction. And what I'm going to do then is simply make 2 into 2 over 1. So I have a fraction, and therefore I can see the denominator and the numerator and the fact that these are going to divide out. 2 divided into 2 is just 1, and we no longer would have the denominator here. We'll eliminate the denominator. Same over here on the other side. I'm going to make this 2 over 1 times the 9/2. And in doing so, we see that the 2's will indeed divide out, leaving us there with 3w plus 2 times 1, nothing's eliminated, 2 times 1 is 2, equals, same thing for 2 times w, 2w, plus, we get to the end here, we see again the fraction, but we have done the multiplication here for a purpose, and the purpose is to divide out those 2's and eliminating the denominator. So plus 9 at the end. And that is the first preparation for this equation. We're not going to solve it immediately as it is. We're going to multiply each and every term by 2, multiply each side by 2, which means distributing and multiplying every single term by 2. And in doing so, again, we're preparing the equation for solving. Same thing here. We need to prepare the equation for solving by getting the variable terms together on the same side. And then we'll go about isolating the variable. And thinking ahead, I'm going to add a negative 2 to each side and eliminate 2w from, I should say, I'm going to add negative 2w to each side and eliminate 2w from the right side. And I'll get all of the variables on the left. So I'm going to add a negative 2w here and a negative 2w here. And then we're going to have an equation that will be simpler to solve. w plus 2, or 1w plus 2, equals 9. And this becomes very simple to solve now. All we have to do to isolate the variable is eliminate that positive 2 by adding a negative 2 to each side. And we end up with w equals 7. And again, I would normally do the check here, but in order to save time, just refer you to the textbook. The check is done in the textbook. Let me check. And It worked. Great. Okay. Well, that concludes our discussion today on Section 2.2. And after seeing this, I strongly recommend that you go back to the textbook and try the exercises there and do some more reading and see anything that I missed. And then prepare yourself for Section 2.3. Okay? I hope you've enjoyed this. And again, please write on the discussion board or in a mail message if you have any questions about this. All right. Good day.